All right, so today we're going to take care of day two of the quadratic formula and the discriminant. Yesterday we focused, or Friday, sorry, we focused on the discriminant. Today we're going to show how that fits in with the quadratic formula. And one of the nice things about the quadratic formula, it can be used to solve any quadratic equation. One drawback is it's not the most efficient. So, how to solve using the quadratic formula? First of all, we want to write our equation in standard form so that it's set equal to 0, and then label our values for a, b, and c, similar to when we were graphing quadratic functions. Substitute the values for a, b, and c into the quadratic formula. One way to think about it, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That square root, that inside part, b squared minus 4ac, is the discriminant, is d. I prefer to write it a little bit different, but any of these three ways would be fine. I like to split the fraction up. B over 2a, negative b over 2a, plus or minus the square root of d over 2a. And the reason I like that method is it makes simplifying the fractions a little bit easier. And so you'll see in the bottom of step 2, simplify the discriminant first. For the approximate answer, use a calculator to evaluate the two expressions, one for the plus and one for the minus. Round to the nearest hundredth. That would be 2 decimal places. To get the exact answer, start by simplifying the radical if it's possible. Uh, Step 5, next split into 2 parts with the plus and minus, with each part over the denominator. So that's why I write it this way in blue. That already splits it into 2 parts. Simplify the first fraction and the fraction outside the radical if possible. So here we go. X squared minus 4x minus 7 equals 0. So the first thing we want to do is calculate or figure out what is A, what is B, what is C. In this case, our A is 1, B is negative 4, C is negative 7. For the quadratic formula, we're first going to try to figure out the discriminant, which is b squared minus 4ac. So negative 4 squared, and yes, the negative 4 needs to be in parentheses. Minus 4 times a times c. So then we could just plug this right into our calculator if we wanted, or we could simplify it by hand. Negative 4 squared is 16. Minus 4 times 1, 4 times negative 7 is negative 28. So I have minus a negative. That's the same as plus a positive. And if I add those together, I get 44. So our discriminant is greater than 0. It's positive. That means we are going to have 2 roots, 2 solutions. So now to find the 2 solutions, I'm going to take the opposite of b divided by 2a plus or minus the square root of d over 2a. So the opposite of b, the opposite of -4 divided by 2 times 1 plus or minus the square root of 44 over 2 times 1. The opposite of -4, that's +4. 2 times 1 is 2. And in our second fraction in the denominator, 2 times 1 is 2. The only thing we have left to do is to simplify that square root. So again, we can use either the perfect square method or the factor tree method. I'm going to do this one with the factor tree, but you could also use the perfect square method, and I'll do one of those later. So the first thing I do is I check for 2. Does 2 divide evenly into 44? Let's see, 44 divided by 2 is 22. Does 2 divide evenly into 22? Yes, 11 times. 11 is prime, so that's it. We're done with this simplification. We have a pair of 2's, so that means we're going to have a 2 out front. And we have a single 11, so the 11 goes underneath the radical symbol. The last step, simplify. 4 divided by 2, well, 4 over 2, or 4 divided by 2 is 2. And in our second fraction, 2 over 2 is 1. So we end up with 2 plus or minus the square root of 11. That is the exact answer. To get our rounded answers, now I'm going to take that and use the calculator. And so I have my calculator. And my solution was 2 plus the square root of 11 5.31662479. If I round that to 2 decimal places, the 6 tells me I need to round that 1 up to a 2. So 5.32. And my other solution will be what I get when I do 2 minus the square root of 11. And the nice thing is with the calculator, there's an easy way to do that without typing everything in again. So I can do second, enter, except I don't want 2 plus, I want 2 minus. So I'm going to use the left arrow and move over, highlight where it says plus and switch it to a minus, and then go to the end and press enter. And there I get negative 1.31662479. Again, rounded to 2 decimal places, negative 1.32. So we have our exact answer, 2 plus or minus the square root of 11. And we have 2 rounded answers, positive 5.32, negative 1.32. And with that, we go on to our next problem. 21 minus 4x equals x squared. You have a couple of choices. We need to write this in standard form so it's equal to 0. One way you can do that is subtract the x squared from both sides. And what I would choose to do then is write it in standard form. So the minus 4x comes next, plus 21 equals 0. The other thing you could have done is added 4x to both sides and subtracted 21. The only difference, all of the signs would be changed. It would be plus x squared plus 4x minus 21. And either way works, and either way gives you the same answer. To use the quadratic formula, I need to find my values for a, b, and c. A is -1, b is -4, c is 21. Calculate the discriminant, the opposite, I'm sorry, b squared minus 4ac, which is -4 squared minus 4 times -1 times 21. -4 squared, and again, the parentheses matter, gives us a positive 16. 4 times -1 is -4, times 21 is -84. So I'm subtracting -84, which is the same as adding 84. 16 plus 84 is 100. To find my solutions, I take and plug into the quadratic formula. That's where we get the opposite of b over 2a, plus or minus the square root of the discriminant over 2a. So we get the opposite of -4 over 2 times -1, plus or minus the square root of 100 over 2 times -1. Opposite of -4, +4. 2 times -1, -2. Plus or minus. The denominator, 2 times -1 is -2. Square root of 100. Well, if I check my perfect square list, the square root of 100 is 10. So now I can simplify my fractions. 4 over -2, well, that's the same as 4 divided by -2. That is -2. Plus or minus, 10 divided by -2 is -5. Put that in parentheses. So my two solutions would be -2 plus -5 and -2 minus -5. So when you add two negatives, you get a more negative number. This would be -7. Here, subtracting a negative is the same as adding a positive. -2 plus 5 is 3. Because our discriminant was a perfect square, we don't have any rounded answers. We only have two exact values. So half the work for that one. Example C. -3x squared plus 4x plus 1 equals -7. Again, we need to get this equal to 0 so it's in standard form. The easiest way to do that, add 7 to both sides. So -3x squared plus 4x plus 8 equals 0. List out our values for A, B, and C. A is -3, B is 4, C is 8. Once we have that, the next thing I would do is calculate the discriminant, which is B squared minus 4AC. So 4 squared minus 4 times -3 times 8. And again, if you wanted, you could certainly use the calculator. Four squared minus 4 times -3 times 8. You don't have to put the multiplication symbol in between, but you certainly could in between the parentheses. The other thing to be careful of, that -3, you need to use the negative symbol, not the subtraction sign. And when we calculate that, we get 112. So our discriminant is positive, means we're going to have two solutions. So we can use the quadratic formula, the opposite of b over 2a, plus or minus the square root of d over 2a. So we get the opposite of 4 over 2 times -3, plus or minus the square root of 112 over 2 times -3. -4, 2 times -3 is -6. And so we have -6 in our other denominator. And so the only last thing we need to do is simplify the square root of 12. I'll do this one with the perfect square method. So check the largest perfect square less than 112, which is 100. 100 does not divide evenly into 112. So then I check 81. 81 does not divide evenly into 112. Then I would check 64. 64 does not divide evenly into 112. Then 49. 49 does not divide evenly into 112. 36. 36 will not divide evenly into 112. 25 would be the next one. 25 does not divide evenly into 112. 16. Well, if I check 16, if we're not sure, we can use our calculator again. We could use our calculator on all of these. 112 divided by 16. Oh, look at that. That comes out exact to 7. Excellent. There is our perfect square and what we have left underneath the radical. So we get 16 and 7. The square root of 16 is 4, and the square root of 7 stays the square root of 7. Reducing the fractions, I have a negative over a negative, so that becomes a positive. And 4 and 6 are both divisible by 2, so I'm going to get 2/3. For the other fraction, again, 4 and -6 are divisible by 2, so I'm going to get 2√7 over -3. Those are my exact answers. For my rounded answers, I'm going to go back to the calculator and see what we get. So we had 2/3 and plus 2√7. I need to arrow to get outside of that square root symbol and divided by -3. And I get -1.097167541. And that just keeps going. So rounding, the 7 says take that 9 and increase it by 1. So it's -1.10. And for the second root, the second solution, I do the same thing, except instead of adding, I'm going to subtract. So again, I'm going to use that shortcut. Second enter. Arrow over to where it says 2/3 plus and make it 2/3 minus. And press enter. And that one, 2.430500874. So the 0 says leave the 3 alone. 2.43 is the other solution. There we have our exact solutions with the square root of 7 in there, and our estimated solutions rounded to 2 decimal places. Right, next example. The next example is a try now. So go ahead and try this one, and then I will work through it and show you how I came up with the solution. So the first step is always going to be rewrite our quadratic in standard form. So I am going to add 2 to both sides. Find my value for A, B, and C. A is 1, B is 5, C is 2. Calculate my discriminant. B squared minus 4AC, which would be 5 squared minus 4 times 1 times 2. 5 squared is 25. Minus 4 times 1 is 4, times 2 is 8. So I get 17. Again, a positive value. So that means I'm going to have 2 solutions. Next, plug into the quadratic formula. Opposite of B over 2A plus or minus the square root of D over 2A. So the opposite of 5 over 2 times 1 plus or minus the square root of 17 over 2 times 1. So -5 over 2. 2 is our denominator in both fractions because 2 times 1 is 2. Square root 17 cannot be simplified. It stays as the square root of 17. So there are my exact solutions. And if I go to my calculator and do -5 over 2 plus the square root of 17 over 2 and -5 over 2 minus the square root of 17 over 2, I can get 2 rounded solutions. Again, you want to be very careful. After you put the square root of 17, arrow over so that the divided by 2 is not underneath the radical. So negative 0.4384471,872. Rounded would be negative 0.44. And then to find the second solution, same thing, just change the plus to a minus. So I like that second enter option. This one comes out negative 4.561552813. And again, it keeps going forever. We can round that to negative 4.56. The one says we don't round it up, we leave it alone. There are my two rounded answers. The second try now problem, again, go ahead and try it. When you're ready, I would say pause the video if you can, and then when you're ready to see the solution, go ahead and play it. First step will always be get this equation into standard form, so I need to subtract 10x. Excuse me. Then find my values for A, B, and C. 2, negative 10, 5. Calculate my discriminant. B squared minus 4AC. So negative 10 squared minus 4 times 2 times 5. Negative 10 squared is 100. 4 times 2 is 8 times 5 is 40. 100 minus 40 is 60. We've got two solutions. We can start plugging into the quadratic formula. Opposite of b over 2a plus or minus the square root of d over 2a. The opposite of negative 10 over 2 times 2 plus or minus the square root of 60 over 2 times 2. So the opposite of negative 10 is positive 10. 2 times 2 is 4. For the square root of 60, again, we can use the factor tree method or the perfect square method. I'm going to do this one with the factor tree. Does 2 divide into 60? Yes, 30 times. Does 2 divide into 30? Yes, 15 times. Does 2 divide into 15? No. Try 3. Does 3 divide into 15? Yes, 5 times. And 5 is prime, so that is as factored as that will get. I have two 2's, so that means I'm going to put 1 2 out front. I have a 3 and a 5 that don't have a like pair. So the 3 times 5 goes underneath, and 3 times 5 is 15. Reduce our fraction. Is there a number that divides evenly into both 10 and 4? 2 divides evenly into 10 and 4. So 10 over 4, when I divide by 2, is going to be 5 over 2. Is there a number that evenly divides into 2 and 4? 2 will. So the 2 in the numerator gets divided by 2. It becomes 1 square root 15. And the 4 in the denominator becomes a 2. And now we have our exact solutions. Using the calculator, we'll get a couple of estimated or rounded solutions. Five divided by 2 plus plus the square root of 15 divided by 2. 4.436491673, or 4.44. And then our second solution would be the 5 divided by 2 minus the square root of 15 divided by 2. So I'm going to go, I'm not going to do y equals. I'm going to go second, enter, and then arrow to the left until I get over that addition sign, change it to subtraction. And then to get all the way back to the other end, if I go second and press the right arrow, that takes me all the way to the end, and I can press enter and get my answer. 0.563083269. So that 3 that's in the third decimal place tells me leave the 6 alone. We get 0.56. And that is how you can use the discriminant and the quadratic formula to solve quadratic equations. Have a wonderful day and take the rest of the hour to work on your assignment.